Hello, everyone. My name is Seth Hendy. I'm one of the education specialists at Healthmark Industries. Happy CS Week to everyone. I hope that you're enjoying it. Today, I'm going to talk with you about care, handling, inspection, and prevention, or CHIP tips for short, which are just quick little bites, things to remember about device reprocessing, and hopefully some tips and some strategies to help you deal with that process better. A quick disclosure, all opinions are those of the presenter, but I will do my best as I go through this program to back up the things that are stated with references to IFUs, references to standards and guidance, so that you know that these are coming from specific sources that you can go back and you can cite. What are our objectives going to be today? Well, we're going to review sterile processing tips in everyday inspection tasks. We're going to understand the importance of proper handling of instrumentation within your department. We're going to reinforce some of the basic technical principles that are used in the sterile processing department. And then we're going to understand the impact that standards and guidelines have in a properly functioning department that processes medical devices. Sterile processing personnel have many responsibilities. I know you know that you're there every day, right? Specific to, of course, we have specific procedures to follow at each point in the instrument processing cycle. And really, other than the transport back, which oftentimes we're at least minorly involved, right? We're providing the case carts or the devices that help transport things back. But other than that transport back to us and the use, we're in every single other part of the life cycle, right? So we're expected to know concepts from cleaning all the way through sterilization and sterile storage. And it makes it a difficult and dynamic job. Today, we're just going to focus on a couple of specific responsibilities, though, right? We're going to look at instrumentation and we're going to look at some regulations. And really, we're doing this with the goal of promoting care, handling, and inspection and prevention of damage to your instruments, equipment, and staff. And so when we get to the regulations part, that's the part that's really going to be about the staff. Okay, tip number one, let's dive right in. Know your terminology. Okay, so I have a question for you. Is disinfection the same as decontamination? Well, I hope that your answer is no, right? Because decontamination is considered the removal of all visible and non-visible and any other foreign material from the device being processed. Okay, fine. That's really cleaning. That's what that is. Disinfection, on the other hand, destroys most recognized pathogenic microorganisms, but not necessarily all microbial forms of life, such as bacterial spores. So that's why disinfection is good, but sterilization, as we'll talk about, has a higher margin of safety, right? That's that middle bullet point there. Here's something to consider though. If an instrument is not cleaned, it cannot be effectively disinfected or sterilized. And why is that? Well, cleaning, we have to remove those organisms. We have to remove that soil first, anything that we can get off, so that our disinfectant or sterilant can make direct contact with the instrumentation. And that's really where that process happens. And I'll give you a very quick story. I had a technician ask me which disinfectant was used in the hand wash sink as he was working. And when I explained to him it was not a disinfectant, it was a detergent, and he was not performing disinfection, he was performing decontamination, his process actually slowed down a whole lot because he had a misunderstanding of the process that he was performing at that sink. And when he understood it, it became much more important for him to slow down and do that decontamination process right. What about tip number two? Well, understand your role. Okay, so here's another question. In a CS department, do we validate processes or do we verify them? We should know by now, because this is a subject that's come up before, that manufacturers validate that an instrument can be reliably cleaned and then sterilized or disinfected and is therefore reusable. A manufacturer validated that to the FDA before it could be placed on the market. What we need to do in our department as users is to verify that that cleaning sterilization equipment is working, and that in the hospital, our cleaning sterilization method is consistently performed. And that should mean what the manufacturer validated, and then is followed by us following that IFU. We're verifying that process can happen. I will just give you a quick thought. That is not always foolproof. And endoscopes and shavers are a perfect example of that, where the FDA has come out and said, even if you follow the manufacturer's instructions specifically, you need to then come behind and do some checking to make sure that that process actually works. So that's an even higher form of validating the fact that that process did actually occur as the manufacturer validated it too. Tip number three, sometimes you must test your tester. Now, I know this turns into a bit of a rabbit hole. Sometimes you say, well, I use a leak tester to test if my scope is working, and now you're telling me I should test the tester. Well, that's absolutely true. This is very important step in whether this process works, right? And because that the one that's pictured as an Olympus unit, because that has a motor and gaskets and seals and all these things that could fail, well, if that device were to fail, then your leak test itself would fail. So we've got to roll that a step back and then say, yes, we do need to check this. By the way, the manufacturer already says you should be checking it every use. Now they're testing it by hearing a hiss. That's a little bit subjective, right? But that is actually the manufacturer saying, oh, by the way, every time you should check for pressure output from this unit. So that should tell you, even Olympus is saying to test the tester, but they're doing it in a way that's hard to quantify. It's very subjective. This is what you should be listening for. Now, hopefully you could hear that little hiss right there, but I would really like you to think, is that as loud as it was yesterday? If somebody else did the testing yesterday, what do you really have to compare to? So, as it turns out, these units, they actually place from the manufacturer, they place a number on whether their unit is functioning properly or not. So with the data from the company that says, ooh, if you're below 4 psi on this unit, we would consider it in need of repair. If there's a gauge out there where you can look to check that pressure, the gauge will tell you 4 psi. Your finger's going to have a little bit of trouble doing that, right? And here are some things to think about. A faulty leak tester is an infection control risk. You will not see small leaks when you start to have pressure problems. And if you don't catch a small leak, it is still a leak in an endoscope, and it can still cause fluid invasion. So it's an infection risk. Incorrect pressure output is a common repair issue, and these units, most of them can be repaired, or in the case of, say, the Olympus MU1, that black cord that you see there, the MB155, that's considered a consumable by Olympus. So they would tell you, you may have problems with this cord, you should buy a new one. So that again tells you that they're subject to wear and potential damage where they would have to be replaced. Listening for that hiss is, as I said, it's a little subjective, but that again tells you the manufacturer is expecting that to be done every time. And then some testers have two parts and they can fail independently. So you may end up needing two testers because, as of course, what gets plugged into the MU1 is different than gets plugged into the MB155. And so to test both of those parts and they both can fail independently, you may need two testers. And then the last thing is send the unit out for repair if it's not functioning properly, or go ahead and buy the new cord if that's the option that you're given. Tip number four, testing insulated devices is a must. Okay, this didn't have its proper due in AAMI as far as I'm concerned until 2020. We used to say that this was a performance um, testing process. You just like testing a scissor to make sure it cuts, because that is the function of a scissor. We would say that you should test the insulation on a coated device, because part of the instrument's performance is that the insulation is intact. But in 2020, there was a new amendment to ST 79 that specifically called out insulation in electrosurgical devices and said that it should be tested each time, because these are a true patient safety risk when they have issues. Now, as I said, we're going to back some of this up. If AAMI isn't where you want to rest your process on, well, we can look at Spectrum for their laparoscopic instruments. At this point in the process, Spectrum recommends testing the insulation for cracks, gaps where the shaft meets the tip assembly and pinholes. That is in the prep and pack section, the assembly and inspection section of the Spectrum IFU. Here's another thought. Do you test all your lap instruments? Great. You test your coated bipolars as well. These are electrosurgical device. And by the way, ST79 doesn't say laparoscopic instruments. They get very generic on purpose, because anything coated is supposed to have the same performance, that it contains electrosurgical energy from where it enters the device to a specific point, mostly the tip, where it is supposed to get out to perform cauterization, and nothing in between. So ASSI, for their bipolar forceps, recommends establishing a procedural review by which the instruments are inspected frequently before and after use for damage such as bullet 3, and that's bullet 3 is for insulated instruments. That's cracks, nicks, lacerations, or abrasions. Another one, because many of us have the V. Mueller bipolar forceps. Prior to use, inspect the device to ensure proper function and condition. Do not use any device if they do not satisfactorily perform their intended function, or if they have physical damage. So there you are again. They're going back. V. Mueller's going back to the performance of this device, and the performance of the coating is to contain that electrosurgical energy. AORN and AST, of course, weigh in. AST is big on this, and that's why I show a little more. They've been out ahead of this curve for a while, and a big piece of this has to do with preventing surgical fire. So you can imagine the Surg Tech organization is big into that. So AORN says insulated devices should be visually examined and tested using equipment designed to detect insulation failures. So they're going beyond the naked eye. AORN is saying there may be defects here that you might not be able to see with your eye, and there is equipment designed to detect leaks. So that's a good quality step to use. AST recommends the following 5 steps for inspecting their insulated instruments in the CSSD. Visually inspect the insulation prior to completing the cleaning process. Instruments or electrodes should be cleaned with a soft, non-abrasive brush, so they're trying to prevent damage there. A microscope should be used to visualize the integrity of insulation of each item. So they're saying, look, your regular eye cannot do this. It's not capable of seeing some of these very small damages. So to go on, an insulated scanner should be used to detect the release of stray electrical energy along the length of the insulation. Right. There you go. So they're trying to very much enhance your optical inspection by calling out a microscope, and then still saying, well, why don't we use one of these devices on the market that is able to detect insulation leakage? Instruments and electrodes are securely packaged for sterilization. So here we are again, preventing damage. And that's the 1-2 punch of this, right? Don't let them, do all you can to not let them be damaged, but then inspect them each and every time, and in a way that you know, with a scanner, with a microscope, with both. Okay. Here's a ST79, the release in 2020 about inspection. And we're just going to look at A here really quick. Instrumentation intended for use with electrical current should be tested for integrity each time it is processed in accordance with the instrument manufacturer's written IFU for inspection. Note, any damage to the coating can compromise the safety of the device. And I just want to show you a quick video here. This is a bipolar forcep experiencing issues because that should be coated all the way to the tip. This is a very, very rough lap instrument that's having a hard time. And the one last thing, what's your compliance with inspecting cords? Because by the way, cords are also an electrosurgical device intended to contain that energy, and they can have nicks and cuts and things like that. And many people are just abuse reusable monopolar and bipolar cords. They throw them in piles. I saw an entire bin of them. All they were rubber banded into the tightest little balls that they could be put into. Well, that certainly can cause damage to your instrumentation. There are various models of insulation tester out there, right? This is just a few. What I really think is interesting is the one that you see on the far left. That actually comes sterile. So the unit itself isn't, but that wand with the cord actually comes sterile so that that could be done immediately before the device is used on a patient. And I got to say, that's a very interesting concept. And if you have a lot of problems, I can see an OR saying, I'm sorry, I'm not going to use a device until I test it myself. Now, I think that an SPD can do a lot to take care of that, where an OR shouldn't have to think, "Hey, I need to test this for myself," But the options are out there for them to do that. Here's what we need to do, and here's what the OR needs to participate in, protecting their instruments, right? Because protecting is key. If you're doing this kind of stuff with your instrumentation, of course, it's going to be a problem, right? Just throwing them in a bin. Now, here's what hurts me a little bit. On the right, they paid more for this organization device, right? We call it that. It's a rack. It's a rack inside your container, but it has silicone holders so that the insulation can't be nicked, so that each item can be segregated from another so that they don't bump into each other. And what did they do? They didn't use it. We opened the door to this case car, and the ones on top fell right onto the rack because just a tiny bit of shuffling, boom, they fell down. Here's the problem. This is what that's supposed to look like. This is why you would buy those trays, why you would buy the extra money to make sure that these things work. So please use them. And the OR does have stake in this. We would rarely send things up that way, the way that you see them, but we receive them back that way, and that's a problem. Here's why. Take a look at this video. Adam, here's a spot. I'm going to stop and go backwards and show this video again, and I'm going to start over. And here's why. You see that unintended tissue burn right there? This is the problem. And the worst part is only because there was a camera pulling back from that shot did we get to see it. Okay. You want the surgical team, you want the surgeon looking right at the point of cauterization. So they're usually just looking at the very, very tip of that instrument, which they should. That's the only place that burning and clipping and cutting should be happening. So that's where we want them to look. Well, what's the problem? Well, when they pulled that telescope back, We see unintentional tissue burning happening when no one sees that. The patient goes home, they feel fine for a couple of days, and then things go downhill fast. So insulation testing is so important within your department. Okay, let's talk about broken light fibers. This is one that I love and that I hate because it's actually something that's very simple to do, yet difficult to quantify. Okay, so tip five is broken light fibers do affect device performance. Optical fiber cables and endoscope should be checked for fiber breakage by holding the distal end against a light source and looking at the cable at the other end. So that's actually quite simple. We have it on our table, we hold one end up to the light, or we hook a device to it that can push light through, and we visualize the other end. So amongst the things that we have to test and that we have to look for, this is a very simple procedure. Here's the hard part. Fiber breakage is indicated by black spots. If you get more than 30% of the fibers broken, the light output at the distal end is no longer adequate. Well, most of these are a nice round shape, right? And if all of the fibers broke in a nice little cluster that looked like a piece of pizza, right? Or a slice of pie, you could go, ooh, that's about 30%. Quantifying what 30% is when the light fibers are broken all over becomes the subjective part. Please take time, when training new staff, when doing competencies for this kind of thing, to slow down and give people strategies, find a light cord that isn't good and then compare to say, hey, this is what 30% looks like, and they're never going to look exactly the same, but you can really see the diminished output in this one. Now let's compare it to your other one. Tip number six, visually is not the only way to tell if instruments are clean. It's where we start. It's where every inspection is going to start. But I want you to look at the little picture on the bottom right. At 100 micrograms, we all know that that's blood. Absolutely. At 10, okay. When we start to get to the 1 and the point 0.1, these things look more like watermarks to somebody. Oh, hey, is that just leftover chemistry? We start to get questions like that. I answered many, many times with my new trainees, hey, Seth, is this blood or rust? They're both kind of the same color. They can present in the same way. And you know what I did? I said, well, if we're unsure, let's test it. And that's what cleaning verification is. You take a tool to verify what you can't see or what you don't know for sure beyond your naked eye. And there are flush methods and there are swab methods, and you can look specifically for blood, or you can look for a combination of different things. And so it depends on the device you're testing and the policy in your department. But there are many, many ways to look for residual soil beyond your naked eye. Tools that can help, and magnification, of course, and that's why all of our workstations have one. A chemical test, right? Looking for a specific marker. And what do your commercially available products do? As I said, some of them are a flush, and a good flush is a combination that might do three soils in one: protein, hemoglobin, carbohydrates. But also there are swab tests for specific residues, like say hemoglobin or protein, and then of course ATP, and that's looking for those RLUs. ATP is a little tough because you have to decide which RLU works for surgical instruments. And I say that because in an environmental capacity, a 600 on a table in the cafeteria, that's probably going to be okay. And they're not going to make a big deal out of that. We would not want it anywhere close to that for our surgical instruments. So make sure if you're using ATP that you've got a realistic benchmark for what you're looking at. Okay, tip number 7. You can have a wire brush. And I know that you're going to be like, wait a minute, what? Stainless steel and brass brushes can be used if an IFU says so, and some do. Okay, so I want to show you, but that's very specific. You may only do this if the IFU says so. This comes from ST79. if the device manufacturer specifies a specific brush or cleaning implement, the brush or an equivalent should be used. So that's a blanket statement of compatibility. If an IFU were to say so, then of course you could use this. So, if the IFU states that you can use a metal brush, then make sure that your policy reflects its use only on that item. And I just gave a couple of things. Up here, this is for cleaning a bipolar forceps, that top right picture. And so the bristles are very small. This is for very precise work to try to clean the tips of a cautery forceps. But of course, and then the bottom one was interesting because that is for cleaning burrs and cement from orthopedic devices, which of course are very, very difficult. But again, that's not all of them. You need to go back to your IFU and you need to say, okay, is this possible for me to do per the IFU? And if the answer is yes, then go ahead. But make sure that you're telling everyone this is a very limited use. It doesn't work on everything. It doesn't belong on every workstation, right? We're using it for specific instrumentation. I'm going to give a pause and I'm going to start this over again. Okay, tip number 8. Now, this is going to be controversial. We have seen the Joint Commission out this year being very, very strict about banding tape, and I do not disagree. I have been to more places that use banding tape and have no policy to maintain it. It is not part of their routine inspection when we watch someone try to inspect instruments. They don't even give a consideration to the banding tape. But there is nothing that says that you can't use it, right? There's no regulation out there that says you may not use banding tape. But I will tell you this: if you look like you don't have a policy, if your staff can't speak to it, and if a Joint Commission surveyor pulls multiple instruments where the banding tape is in disrepair, chipped, flaking, or having a problem, then they are going to pull that rug right out from under your feet. Here's the thing: if applied correctly and maintained, it does have support. Okay. SC 79, section 741. When used properly, you can use plastic dip or instrument tape, but these types of markers wear out over time and the staff need to inspect them each time the instrument is processed. If you cannot guarantee that that's happening, you probably shouldn't have tape within your department. What about AST? That's, again, it's not just Amy necessarily. Manufacturer's instructions and healthcare facility policy should be followed for the use of colored tape and plastic dipping materials for the identification of specific surgical instruments. Studies have confirmed that the use of colored tape does not interfere with sterilization. So that's not the problem, and that's not what Joint Commission are saying either. It's really not the sterilization process, it's the cleaning process. But then if the cleaning process can't happen properly because your tape is just not maintained and it's holding on to debris and bacteria, then the sterilization process won't work. And I couldn't help it. I found one. I found a picture that was everything wrong all in one photo. And there's a few things here. If you're going to apply your tape correctly, some things to think about: that it should be clean and dry in the application area. Wipe with alcohol and allow the alcohol to dry. Firmly press tape and don't stretch it. Wrap tape 1 to 1.5 times around, and the tape should lay flat without gaps. Well, what do we have here? We have tape not fully wrapped around. This didn't make the 1.5 times. It has a big giant gap. There's residues sticking out, and this overlap is not good on all three of these. When you're doing inspection, inspect tape prior to each use. Identification tape is not intended as a permanent mark and will discolor, break, chip, and flake over time. And you have to replace it as soon as that is seen. And if you're not doing that, you're going to have a problem at your next survey. What about those little 3D barcodes, the key dot or info dot? Another type of instrument tracking that's applied directly to a device, gets down to the device level tracking. It's like color coding, but it uses a small barcode. It links things to specific sets, easy to identify individual instruments for labeling. You still have to follow the IFU for the way it's applied, and it has to be inspected every time. If they begin to flake, chip, or pick up debris, you cannot use those either. Okay, tip number 9, data can help solve problems. Sometimes I know we don't love to collect data for things, but it can. Mechanical washers are complex machines that require programming, giving specific times, temperatures, and concentrations of detergent to know that they're properly functioning. Many washers have different cycles for different applications. For example, instruments, glassware, plastics. So why is that? Well, each cycle has different sets of times, temps, and chemical exposures because they are for different materials. So whether changed intentionally or accidentally, manufacturers' preset cycles can be altered. So this may result in ineffective cleaning, right? Sometimes people will say, I took a minute off the dry time, or I mean, you name it, right? Because to shave a minute doesn't seem like a lot for an individual cycle, but then if you're a 24/7 department, somebody thinks that they're saving minutes to hours a day in their cycles, but it causes problems. Now, there are ways to plot cycles. You can put devices in a washer and let it go through, and it will look at times and temps. So there's a few things here to look at, and you get better at reading these plots the more practice you have. Here are some problems we see on this one. Pre-rinse and enzyme are blended, but there's not enough time. It typically needs around 3 to 5 minutes, and this one is short. It's less than 3 minutes. The next phase that happens is we go into the enzyme cycle, and that cycle was too hot, right? 140 degrees. Most enzymes die at or above this temperature, right? Usually enzymes should be at 120. So this is 20 degrees warmer than most manufacturers would recommend their enzymes being used. So instead of those enzymes giving us the action, the cleaning action that we want, that they're supposed to help with, we've killed them off because it's too hot, and now they're inactive, and now we wonder why our washer doesn't perform as well as it should. Then sadly, we have a dip at a point where we expect it to go up. Detergent cycle temp is too low, right? That needs to be around 150. And if you're using an enzyme and then a detergent, you'll normally see the detergent itself doesn't have enzymes in it, so you don't have to worry about the enzymes being a problem because the enzyme part happened first, and then the regular detergent cleaning that doesn't have enzymes is in the next phase, and it can be higher. Now, this is the second part of the plot, right? This finishes out the cycle. And we see here that it's too low. I'm sorry, that's where we pick up again. So that's where the detergent cycle was, and we wanted it at 150, and that was too low. Then we get over to the final side here, and then this dry is too low. Typical temps around 210 to 240 degrees. So the instruments in this cycle came out very wet. Now, instruments may not come out bone dry, but these came out very, very wet. Everything was dripping, soaking wet everywhere. And that's because that temperature is typically a little bit higher than what it is there. So washers can fail to clean for many reasons, but time and temperature are usually your key factors. So something like a data logger, which is from the plot that I just showed, can monitor this, and especially with washers that don't come with printout tapes anymore, and there's many of them that don't. You actually would have to stand there and watch the cycle on the display itself. This is a way to stick something in, walk away, plug it into the computer, and then look at the cycle objectively after it's done. Okay, tip number 10, checking your eye wash station. That is actually a law. So we've gone into OSHA here, and this is not something that can be not done, or it's not a voluntary standard. This is the law, and if we're not doing it, then we run the risk of violating a regulation and having fines and things like that. So guidance for checking eye wash stations come from several organizations. Here's an example. Now, of course, Amy, ANSI, AORN, all of those places recommend checking the eye wash station because they have to say that OSHA, as a regulatory body, has written a law that says we have to have these eye wash stations, and if we have to have them, we have to make sure that they work. Right. So of course they back up that regulation in their voluntary standards. The OSHA requirements for an emergency eye wash and shower found in 29 CFR, that's 29, the CFR is Code of Federal Regulations, specifies that where the eyes or body of any person may be exposed to injurious corrosive material, suitable facilities for quick drenching or flushing of the eyes and body shall be provided within the work area for immediate for emergency use. So here's the a thing that I see all the time, and something that you have to consider for yourself. I go into many places that don't have an eye wash station in the assembly area or have recently removed it. And I have to say, and I know this will come across as a little cheeky, but I say it this way. So there's nothing in this assembly area that could be considered injurious to your eyes. And people say, well, no, I mean, we have alcohol for disinfecting our workstations. Okay, if that were to get into your eye, they would expect it to be flushed. And then I usually point to the low temp sterilizer, which is usually not very far away from assembly, if it's not right in that area. And I say, oh, so people from here could walk over and be dealing with these chemicals, which are sometimes in a liquid form, that's a cup that gets inserted into a machine that could be subject to spill. So when you really start looking around your assembly area and you start to think, oh, there are several chemicals in here that I would not want to get into my eyes, and if I did, I would like to be able to flush them. And then we look up and there's no eye wash station within 10 seconds in one door. That is the rule. And the door has to swing open, by the way. So you can't have to pull it, you have to push it. So if you're standing in your assembly area and you think that it would take more than 10 seconds, which is usually about 10 big steps, and you have to go through more than one door, and that door isn't a push, then you would say, okay, I'm actually not in compliant with this OSHA regulation, and it looks like maybe that eye wash station has to come back, or I need to ask for one to be installed. So while not having the force of the regulation, the current ANSI-AMI standard addresses emergency eye wash and shower, and it provides for eye wash and shower equipment in appropriate situations when employees are exposed to hazardous material, right? So again, that is because ANSI-AMI is a voluntary organization. You don't have to follow them, although it's a great idea to do that. They have great materials that they put out, and I would always say, why reinvent the wheel if this best practice kind of guidance is out there already? But no matter what, you're going to have to default back to OSHA, and that is the law. Uh, Each month, OSHA publishes a recap of noted violations and fines levied, right? So non-compliance often begins at $100,000 and can exceed $1 million. So it depends on how egregious your violation is, but your base level, if they come in and they see a problem, is going to be 100 grand, and it's just going to go up from there. Non-compliance with drenched showers or eye face wash present significantly higher risks, incurring $213,000 worth of OSHA fines for a blocked eye wash station. So that's nothing to do with it, not even not functioning or not being tested. They're just saying maybe your eye wash is in perfect condition, but you put something in the way of it. So there's a $200,000 fine, even if your equipment works flawlessly, let alone having them come in and find out that you're not testing it, that the water isn't tepid. There's multiple things about the actual function of the equipment that could make things even worse. So the ANSI document Z 358, section 462 and 465 talk about eye washes, require weekly activation of emergency shower and eye wash to confirm proper operation, along with a thorough annual inspection. Tepid water is specified. So why tepid? Well, in an emergency, the unit should provide water that's not too hot or too cold. You may have to flush your eyes for 15 minutes. And if something is too hot or too cold, of course you're not going to be able to keep it in there. We have many places that say, when I ask, do you check it for tepid water? They say yes, and I say how? And they say, well, I stick my fingers in there, and if it's if it's lukewarm, it's not too hot, it's not too cold, that's tepid. If OSHA didn't give a definition with a specific range, then this could probably work. But I have to say to you, your fingers can tolerate things that your face and eyes could not. So something that does not feel too hot or too cold to your hand might feel extremely hot or extremely cold to your face, for one. For two, if something were at 55 degrees, could your fingers tell if it was 55 degrees and not 60? I kind of doubt it. But since there's an actual range, a defined range for tepid water, we really need a objective way. Not, my fingers don't feel too bad, so I think that's okay. No, we need a way to say it was 67 degrees, boom. That is exactly where, that's exactly in the range that it should be, and I am in compliance with the tepid water recommendation. The decontam area is usually where we see them for sure all the time. And many places default their assembly eye wash to decontam. Again, if that's within 10 seconds and the door swings the right way, then that could be acceptable. But I have to say, our eye wash station that was in decontam was too far away from assembly for that to work. If we are talking about it in decontam, suitable eye wash shower equipment must be available with unobstructed access, located within 10 seconds of where chemicals are delivered, maintained in accordance with the IFU, tested and documented, and eye wash stations should not be in a location that requires flushing of the eyes in a decontamination sink. There's the other thing to consider. If you have those, the ones that are mounted on a faucet, but that faucet is mounted on your 3 sinks for cleaning, then that is unacceptable. There's too much risk of contamination, and the thought of putting your eyes in there is not good. So if that's where your eye wash is, that's no good. Now, if it were on your hand hygiene sink, that is completely different. But your hand wash or instrument sink, that's a no. And then I just have to show you a couple of things that make my eyes hurt, frankly. Would you use either one of these? If you really had an emergency and you were trying to flush things out of your eyes, would you feel comfortable putting your face into either one of these? One of them's just holding garbage and has a bunch of stuff. The other one actually has a few pieces of instrumentation in it, because I don't know, because they fell on the floor, and the best place to put it is this, yellow bowl right in front of me. And so in goes washer tapes and instrumentation. I would not use either of these, and that's a dangerous situation. Now, this is a little better, but I only say a little. there's cleaning procedures for these. So there's obviously build up and scale things happening here. Someone is not placing the covers back on these, and this is not something that I would feel comfortable putting my eye in. Yet if I had a problem, and I actually did splash chemicals in my eye and I didn't want to lose my sight, this would be my only option. Improper or no cleaning isn't the only way for eye wash stations to be out of compliance. Leaving the caps off the nozzles, that's usually stated in the manufacturer's IFU, so that's a problem. Not testing the station regularly, of course, not recording the testing. If you're doing it, the fact that you don't record it, it's just, it's too bad. You're spending the time to put this needed, necessary quality process in, and then you can't prove it, or crowding the station with carts and supplies. These are all ways to be out of compliance with 29 CFR. I couldn't help. Unobstructed access, is that what that looks like to you? No way. There's no way that tucked in that, I have to move this cart, and by the way, that cart's not on wheels, so that would have been easy, and maybe pull out the dust mop that's there, all to try to flush my eyes. All, by the way, well, I probably can't see, right? Well, my eyes are closed and painful and I can't see. I've got to make this work. This looks correct at first. Now I'm gonna forego the fact that it's missing one cap, but this is clean. Things look okay, right? But then we look and the record is blank. And when we asked, we said, well, do they keep it somewhere else? And they said, no, no, they don't keep it anywhere else, which is worse. But we've had a few places that say, well, no, we keep this eye wash check record somewhere else. And then I say, then please remove that, because it looks like you're not keeping your record at all, which is not true, right? It's just maintained somewhere else. So if you have one of these but don't use it, don't leave it on the eye wash station, because then it looks like you're not testing at all, even if you are. One last thing to think about for eye wash stations: bottle style eye wash stations are not acceptable in the decontamination area. They have to be hands-free now. You have to be able to pull a valve, push a paddle, you name it. But it should be, you initiate the eye wash and then it just goes, and it has to be able to go for up to 15 minutes. So that squeeze bottle where you're forced to keep squeezing it yourself doesn't work. And then there are some larger tanks, that are running under the same principle, except we know that they don't have enough water to run for 15 minutes. What about testing that station? Plumbed eye wash and face wash should be activated weekly for a period long enough to verify the operation. And that is to verify that they are providing lukewarm water. And um, we have that recommendation for what that is. This is here in Celsius, 15 to 43 in Celsius, or 60 to 100 in Fahrenheit. And that they're running and working. All right, to finish up here, sterile processing department is a detailed and dynamic arena, staying current with recommendations and techniques required for SPD professionals to be knowledgeable, motivated, and innovative. Right? We need critical thinking. Right? We need risk assessments. Right? That's what our department is coming down to. That not everything is as cut and dry as we would like it to be. Certification and continuing education are key to excelling in this fast-paced environment, which is why you are all here today, right? This is why we celebrate CS Week, because we all know that this job is extremely important, and I thank everyone for doing it. One final closing thought, and I say this wherever I go, wherever you're listening to this, if I were to show up there to speak for you or to perform a review in your department, in your hospital, you become my home hospital. So, you know, I try to think of every one of your departments as my home SPD and my home hospital, because for however long I'm in your state or I'm in your town, you are my home hospital, and I really appreciate that, and I hope that we all take it as seriously as so many of the people I see in the industry do. Thank you very much.